Hi, my name is Jingjie Zheng from University of Waterloo. My supervisor, Dan Vogel, and I did a work called FingerAware Shortcuts. It's a new way of accessing keyboard shortcut keys. Anna talked a lot about using specific finger to press specific key. Our work is also similar to that. So keyboard shortcuts, also known as hotkeys, are a ways of issuing commands using one or more keyboard keys. It can be different combinations of modifier keys plus an alphanumeric key, or in some applications like Photoshop, it could also be pressing single key when it's not using non-text entry. So people use keyboard shortcuts, especially expert users like programmers, video editors. They use keyboard shortcuts to help them speed up their workflow. There's a nice quote from Donner News. He was talking about using Emacs as if playing an organ. So in the research related to keyboard shortcuts, there are four major challenges. The first two are related learning and fostering use, as a lot of literature suggested that keyboard shortcuts are actually underused by a lot of users, even expert users. So assuming the first two problems got solved, and they are successful, our question is, how can we provide as many as keyboard shortcuts as possible? This is related to two concepts. One is availability, the other is expressivity. Availability is defined in terms of how many other modifier keys you have to press, or what kind of mode you have to enter before you actually trigger a command. You can't just always press a single key. Well, expressivity is defined in terms of how many commands can you get out of the single key. So the big idea of FingerAware shortcuts is to change the key behavior based on what hand, what finger, and what hand pose you're using. So here's a good example of FingerAware shortcuts. When you press the same G key, you can actually issue different commands. For example, when pressing G with your index finger is touch typing, you simply enter the letter G. When using a closed hand, you issue go to line. So when you use the right hand and different finger, you can issue go to page, go to class, grab, or grab, depending on which finger and what hand posture you're using. So our system recognizes what kind of hand posture you're using to press the same key, making all these keyboard shortcuts instantly available. So just in case you fall asleep in the rest of my talk, I'm just giving you the main result of our study. So we did a formative study showing which finger and hand pose combinations to use and which ones to avoid. We implemented a computer vision-based method to check hand and what finger and what hand pose they're using. We did a performance study to compare the FingerAware shortcuts towards conventional keyboard shortcut mappings, and we found that it's comparable to using multiple modifier keys with the same key. And finally, we give some demos in different applications and even ideas beyond this idea. So there has been previous work. The idea being changing how physical button works depending on which finger you use. So people use a finger scanner connected to a laptop or maybe a color marker on a sheet of glass to identify which finger they're using. These have been pretty early work, and neither of them were using a full keyboard, and they only identify finger, not hand pose. And neither of them explores the performance of preference, also like design space for shortcut-like command activation. So if you think about it carefully, there's actually a big potential input space just out of your hand. You have two hands, 5 fingers, and we devise 2 hand poses, open versus closed. So this will give you this will give you up to 20 different hand postures per key press. So the first thing we thought about is to reduce the set of postures that people like to use. and they are fast to perform. So we let 20 participants do all the hand postures, pressing different key areas after either they type something or they point something on the screen. So here's a view of how the task looks like. You can see that the participant alternate between reference tasks and press the key with posture indicated on the display. It's important to notice that there's a rehearsal stage where the participant will see the posture first and perform the posture to rehearse and do the reference task, and then to come back to the same posture to use the same posture to press the same key. So what we really want here is the physical performance, not the cognitive overhead to try to identify what posture is on the screen. Also, it's up to participants to perform the right posture, and we manually examine they are doing right or wrong afterwards. So this gives us a really pretty low error rate of 1.9%, which breaks down to less than 1% of using actual wrong posture. What it's saying is that we are having really good data and people can do this kind of task. More interesting is to look at the time and preference of using these postures. So we have open hand versus closed hand. If you look at the both graph, you can see the symmetric pattern between the dominant hand and non-dominant hand. And so we come up with a guideline based on what finger and what hand pose to use. So you can see there are recommended postures like index finger with either open or closed hand. They are fast and they're highly preferred. Also thumb with closed hand. Thumb with open hand also seems to good, but participants complain about, especially bigger participants with bigger hand, they complain about using this posture will make them hit the screen, so we exclude this posture from the recommended list. As for the posture to avoid, there are two postures. One is ring finger with closed hand. You can imagine why it's even really hard to articulate. Middle finger with closed hand, although the time seems good and preference is good too, but in many cultures it has a really bad connotations, so it's strong enough for us to avoid it. So I'm going to briefly talk about the implementation of our system. In many laptops you have built-in webcams, and we simply mount a mirror onto the webcam to redirect the light path to see the rectified keyboard area. We also cheat a little bit. There's a green cover to help us do the background subtraction, but with better camera and maybe better algorithm, we can get rid of it. So we implement this full pipeline of tracking algorithm. It's robust enough to conduct the performance study that I'm going to talk later. So I'm just going to give you some buzzwords for tracking. So first, we use a Gaussian naive-based classifier to isolate hand contour, a previous approach for finger localization. And something interesting to the HCI community is that we treat the hand contour as a unistroke, then use $1 recognizer to help us to identify what shape it is in order to help us identify what posture it is. And we also use some heuristic rules as well. We use common filters to track fingertips or frames, and finally, we implement a CoCo application to help us intercept the keyboard event over the whole operating system, which makes FingerAware Shortcuts available to every application in the computer. With this implemented system, we did a performance experiment. The big question is how are FingerAware Shortcuts compared to the keyboard shortcuts that we use every day in terms of time and error. So similar to the formative study, we compared FingerAware Shortcuts with 3 conventional keyboard shortcut mappings. So basically, we have two sets of random 4-letter words as command starting with the same letter. We try to map them to either the same key or different key with or without modifier. So as you can see in the three key condition, just like pressing the single key in the Photoshop, and 3 key 1 modifier condition, just you have 3 different keys plus a commonly used command as the modifier. And 1 key 3 mod is it's like the scenario you press the same key with different combinations of modifier. And finally, it's the same key with different postures. So here's a view of FingerAware condition of this experiment. It's very similar to the formative study. The participant will do the reference task and trigger the commands. There's a cheat sheet accessed with a space key to help the participant understand and memorize these commands. And we did a multiple block study, so you can we actually found that cheat sheet view and time and count dropped sharply after the first block, so the participant mainly rely on their memory to perform this task. This gives us a pretty reasonable error rate of 6.9, which is comparable to other standard shortcuts. So when you look at the time, you can see that 3 key and 3 key 1 modifier condition are actually really fast. And FingerAware shortcut condition is comparable to using multiple modifier key plus the same key shortcuts. It's important to realize that it's actually a good result because, first of all, FingerAware shortcuts is not a well-practiced task, and because of the computer vision causing error and stuff, people have really high frustration rate. Also, FingerAware shortcuts, if you think carefully, it's not mutually exclusive from these standard keyboard shortcuts. So, finally, I'm going to show you some demos using Photoshop and Google Docs and some other ideas to show how can we map commands to FingerAware shortcuts. So first idea is called complementary commands. You can overload a family of commands such as changing the heading style to heading 1, heading 2, heading 3, or return to normal text by pressing the same H key with index finger, middle finger, and ring finger. Another idea is you can override the action of up and down to 2 different fingers and press the key related to the command. For example, you can press the B key to adjust brightness, O key to adjust the opacity of an image. And you can also treat this one certain posture as a command modifier. And when you use this posture to press the B key, it will turn the text to bold. I key will turn text to italic. And something more interesting is continuous input. You can recognize the location or the angle of the thumb when you press this one key to adjust the RGB color. Or you can switch items in the context menu like this. And when in some rare conditions when you want to log out, such command you can actually use 2-handed posture to press L to log out. Dan really loved this idea. So in conclusion, our work introduces the idea of FingerAware shortcuts as a viable method for augmenting current shortcut keys. Thank you.